Securing the shell. In this nugget, we're going to be talking about Windows PowerShell's security features. We'll start by discussing scripts. Scripts are really the big security concern, and they're the area where Windows PowerShell applies most of its security functions, and I want to kind of talk about where that concern came from. Then we'll dive right into Windows PowerShell's security features, starting with its script execution policy. Now that's going to kind of lead us on a little bit of a tangent, talking about script signing and digital signatures and digital certificates, but we'll come out of that, and I'm going to make sure you understand why that execution policy is so important by explaining Windows PowerShell profiles and how they can be used as a backdoor through whatever security you've come up with if you're not careful. We'll wrap up by talking about two last security features: the fact that a path is required when you execute a script, and the fact that the file name extension association with Windows PowerShell is in itself a security feature. So why are scripts such a big security concern in Windows PowerShell? Well, to kind of illustrate this, let me step back from Windows PowerShell for a second. Let's take a look at VBScript. That was Microsoft's sort of original official scripting language, and we certainly know that there were some security concerns around it. So I'm going to right-click here on the desktop and create a new text file and call it test.vbs. Alright, here's something that'll mess you up. Let's go to my computer here, and on the Tools folder options, reconfigure the view to not hide file name extensions. This will mess me up not only for VBScript but for PowerShell because it prevents me from seeing this extra .txt on the end. So let's truly make that a VBS file, and then I'm going to right-click it and select Edit. Now we're not trying to learn VBScript here, so I'm just going to make this a very, very quick wscript.echo hello. So this will just display hello. If you don't know a thing about VBScript, just trust me, that's going to display hello. Here's the big security concern with VBScript. I'm a user, I get this in an email, it says it's a postcard from your mom, double-click it to open it, I double-click it, and the script runs under the Windows script host. Now my script just said hello, but it was more common in these viruses for the script to do something malicious. Maybe grab every address out of Outlook and send the virus on to all of those. Or erase files, or erase, if you're running as administrator, erase objects out of Active Directory. There were certainly a lot of malicious things that could be done. This type of behavior is the type of thing Windows PowerShell was designed to prevent. When the Windows PowerShell team sat down at Microsoft and said, we're thinking about writing this new tool that's going to have scripting capabilities, red flags went up, alarms went off, sprinkler systems were activated, women and children cried, men gnashed their teeth, and people were concerned. The fact is that scripting didn't have a great reputation at Microsoft. But the PowerShell team said, no, what we want to do is take everything about the way VBScript worked and throw it away. We want to get rid of it and learn from those things and sort of start fresh with scripting and really think about how it's going to be used and how we can keep it from being used maliciously. So let's talk about some of the things that the Windows PowerShell team was trying to prevent when they decided to create the shell. One of the problems they noted about older forms of scripting in Windows is that they didn't offer any kind of integrity. When you got a script, there was no way of telling if it had been modified since it was originally written. That means somebody could write a perfectly beneficial script, a piece of malware could go in and modify the thing, and you really had no indication of what was going on. In a really large script, 200 or 300 lines maybe, there's no way to just sit through and read the script every single time you're going to execute it. The other problem, which is kind of related, is the fact that there was no identity. When you got a script, there was no way to confirm who wrote it. So if the script turned out to be malicious, there was no way to track down the author and beat them up with a baseball bat. Another problem, and this came in more with batch files than VB scripts, was an attack called command hijacking. Now this was a situation where you would go to a command line, run a command like dir, or maybe an external command that you're used to using like ipconfig or nslookup or traceroute, and instead of running the command you thought you were running, you were launching a script or batch file that happened to live in the folder that you were in at the time. So you always had to be cognizant not only of the hierarchy of the order in which things were run. Does the shell run built-in commands and then look for batch files and then look for executables? But you also had to be aware of what it is you were running, a command, a batch file, or an executable. And for example, ipconfig, a lot of people would just forget that it's not really a built-in command. It's an external executable. And you also had to be aware of what else was in the current folder or the search path that might interrupt whatever you were trying to do. So anyway, it was really complicated, and it was very easy for command hijacking to occur. And the last behavior that they really needed to avoid was the fact that you could double-click a script to run it, just like I did with that VB script. And that's certainly a problem. You shouldn't necessarily create scripts as executables, especially when all these other problems exist. So these are the things that the Windows PowerShell team set out to solve. One of the features they added to Windows PowerShell to help solve these problems is something called the Windows PowerShell execution policy. And there are 4 levels of execution policy in Windows PowerShell. The first level is simply restricted. Now, the nice thing about the restricted policy is that no scripts will run when the restricted policy is in effect. This is actually the default policy of Windows PowerShell when you first install it just out of the box. All the way at the other end of the spectrum is unrestricted. Unrestricted is the exact opposite in that it will allow all scripts to run. I don't think this is an appropriate execution policy under any circumstances, either in a test development environment or in a production environment. What I like to use in a classroom such as this one, or in a lab or a development environment, is the remote signed execution policy. This says that local scripts that are actually sitting right on the same computer where I'm running them, those will run without a signature. Anything that comes remote, something from a UNC or a script that you download with Internet Explorer, Outlook, or Firefox version 3, those scripts must have a signature, a digital signature applied, or they won't run. So this is good for a test environment, or a production or a non-production environment, a classroom, a development environment, whatever you want. For a production environment, the execution policy I like to use is called all signed. And this one's real simple. All scripts must have a signature. And we'll talk in just a moment about what signatures are and how you get one onto a script and how PowerShell looks at it. But since we've got these 4 different execution policies, restricted, all signed, remote signed, and unrestricted, you're going to need to know how to actually configure those on your computer. And there are 2 ways. Way number 1, which is the way I'm not terribly fond of, is to get in PowerShell itself and run a command called set execution policy. And all you do is you type the name of the command, you follow it with the execution policy you want, restricted, all signed, whatever, and you hit enter. You do need to be an administrator, and the shell has to recognize that you're running as an administrator under elevated privileges in order for this to work, because it's actually modifying a registry key under HKey local machine. The better way to do this, though, is to push it out to your entire organization by using a group policy. So if I go to www.microsoft.com/download, and in the download search box, you have to be a little careful not to punch it in this. No thanks, I don't want Silverlight. Don't punch it up here. Punch it down in here where it says search all downloads. Type PowerShell ADM. Hit go. And you'll find an ADM template for Windows PowerShell. This will allow you to extend group policy so that you can configure all your computers with a standardized Windows PowerShell execution policy right through Active Directory. So that's the way I recommend you do it. That way you don't have to go to every single computer. And the cool part is if you get this administrative template in place now, then you're configuring computers that might not even have Windows PowerShell installed. So once Windows PowerShell is installed on those computers at some indefinite point in the future, you'll already be on top of it. You'll already have a good execution policy in place. Okay, so execution policy, great, relies on digital signatures. What are digital signatures? Well, why don't we start by taking a look at a digital signature? The easiest way to do this is probably to look at some of the configuration scripts that come with Windows PowerShell. Windows PowerShell is installed in C Windows System 32, Windows PowerShell v1. And you'll notice several files in here. One of them, or many of them, are these PS1 XML files. I'm just going to right-click and edit types.ps1xml. And I really don't care what's in here. I just want to go all the way to the bottom and look for this digital signature. This is a digital signature in a script. It really encompasses, well, several things, but two important things. The first important thing is the identity of the signer. Now, in theory, I could take this entire signature, paste it into a tool, and the tool would tell me what certificate was used to sign this script. Because certificates are issued to individuals and companies, this signature is actually telling me who signed the script, either the name of an individual or the name of a company. Now, in this case, I already know that it's Microsoft. That's who gave me this file. The other important thing, though, that this signature includes is an encrypted copy of the script itself. So we start with the clear text version of the script, and that's what PowerShell is actually reading and executing. But this contains an encrypted copy of the script. Here's how Windows PowerShell uses that encrypted copy. I start off with a script file, just like this one. Now that happens to be a PS1 XML configuration file. Normal PowerShell scripts use a PS1 file name extension. And in addition to the clear text portion of the script, I have this gobbledygook signature at the bottom, a portion of which is identification, and another portion of which is an encrypted script. PowerShell takes the clear text script, decrypts the encrypted bit, and compares it to the clear text bit. If they match, then the signature is said to be intact. If they don't match, let's say an unsuspecting user or a piece of malware has come in and modified the clear text version of the script, well, in that case, the signature is not going to match any longer, and PowerShell will refuse to execute the script because the signature is no longer intact. Instead, you'll actually get an error message in nice red text when you try to run the script. So that's one way in which PowerShell actually uses these things. So where does this all come into play with the all-signed execution policy? Well, let's say I have a script I want to run. And I've got a computer that I want to run it on. There's my little computer. I run this script on this computer. This script is not signed. Windows PowerShell is using the all-signed execution policy. The first thing Windows PowerShell asks itself, is this script signed? Well, the answer is no. Okay, all done. The script doesn't run. Don't need to think about anything else, just not going to run. How do I get it to run? Well, I need to go out to a certification authority, or a CA. Now, this might be part of your internal public key infrastructure. It might be a commercial CA like VeriSign or Thought or CyberTrust. Doesn't matter. They're going to issue you a digital certificate. And they're going to issue you a particular type of digital certificate. This is called a Class 3 code signing certificate of the Authenticode type. Authenticode is just Microsoft's brand name for script signing. Netscape has one, Java has one. This is Microsoft's. So I get a Class 3 Authenticode code signing certificate, and I use a command in Windows PowerShell called set Authenticode signature. I just give that command the certificate I want to use as well as the script I want to sign, and it will apply a signature to my script. So now my script is signed. There's my little signature. Remember, that includes a encrypted copy of the clear text version of the script as well as my identity. This certificate represents my identity. We'll talk about that in just a second. So now I go to run the script. Windows PowerShell is actually going to run three little checks. The first one is the same one. Is the script signed? Well, it is signed, so the first check passes. Is the signature intact? This is the bit where Windows PowerShell compares the clear text script to the encrypted script in the signature, makes sure that they match, and if they do, I pass that check. The last check is, does this computer on which the script is running trust the CA that issued the certificate? If it does trust the CA, then the third check passes and the script will run. Well, what does that mean, trust? Now let's take a look. Let's jump into the control panel and open the Internet Options control panel. Go to the Content tab, open Publishers, and switch. Well, you can see I don't have any trusted publishers, but really where you'll find most of these is on the Trusted Root Certification Authorities. These are my Trusted Root Certification Authorities. If a certificate is issued by one of these guys, or by a CA that they have authorized as a subsidiary, then I will trust that certificate. And I will trust any PowerShell script that has been signed using one of their certificates. So let's talk about why this trust business is important. Let's say that I've got some person out here and he plans to write a bunch of Windows PowerShell scripts. So he needs to get a certificate, and the way he's going to get a certificate is to go to a CA. Let's think about what I'm really relying on from that certificate. I want it to tell me the person's identity, so that if this script turns out to be malicious, I can use the signature to derive their identity, and then I can go beat them up with a baseball bat. Or conversely, if the script is really beneficial, maybe I want to use the signature to find out who they were and buy them a nice present. So the real thing I'm getting from a certificate is identification. A digital certificate equals identity. You can think of it as a driver's license or a passport. So when I say that I'm trusting a CA, what I'm trusting is that they do a good job of actually validating someone's identity before they give them a certificate attesting to that identity. In other words, before they hand out a certificate that says, this is Don Jones's certificate, they do a good job of making sure they're actually giving it to Don Jones. If they're going to give it to someone else, if their procedures aren't good, then I don't want to trust them. Because if Ken Smith can wind up with a certificate in his hand that says Don Jones, well, that does me no good. If I reverse engineer the signature, I'm going to find Don Jones and I'm going to blame him for the script, when in fact it was this Ken guy who did all the nastiness. So trusting a CA means you understand their procedures, and that you're comfortable with their procedures, and that you think they do a good job of validating identity before they go handing out a certificate. Well, if you don't know what this particular person or this particular person is actually doing, if you don't know their procedures, they shouldn't be on this list. Your Active Directory administrator can use a group policy object to configure this list. That can include adding trusted root certification authorities that your company trusts, such as your internal CA, for example. And it can include removing ones that your company isn't familiar with or has decided that they specifically don't trust. So by getting your trust under control, you also get Windows PowerShell under control. The all-signed execution policy makes sure that only trusted scripts will run. So in this way, you can really sort of control the scripts that run in your environment. Sure, it's possible for a malicious script to run, but if you've configured your trust properly, you'll always be able to find the identity of the author and beat them up with a baseball bat. Now you might think to yourself, well, that all-signed execution policy, having to sign every single script before I run it, kind of sounds like a hassle. So I'm just going to go with the remote signed execution policy, because my local scripts, well, they're all ones I wrote, and they're all ones I trust. Yeah, okay, let me show you why that doesn't work out. I'm going to run Windows PowerShell so you can see what it's doing when I launch it. Displaying a little banner here. It's placing me into my administrative folder. Okay, let me close this. I just want to prove that I'm not doing anything magical here. I'm going to go into my Documents folder. I'm going to create a new folder called Windows PowerShell with no space. And then in that, I'm going to create a file, just a simple text file called profile.ps1. I want you to think about this. I have full control over my Documents folder. Any process running under my logon also has full control over my documents folder. That's kind of the whole point of it. I'm on Windows Server 2008, but prior versions of Windows actually called this My Documents, not just Documents. So a piece of malware could actually go in and do what I've just done. Create that folder, create this file, edit this file, and put some potentially malicious Windows PowerShell commands in here. Now, I'm not going to do anything malicious. I'm just going to say write hello, because I want you to see what happens. But it'll run any command. For example, I might tell it, you know what, change to the root folder. So let's save this, and then run Windows PowerShell. Oh, look, hello. And that's because I'm running under the get execution policy is going to show me that I'm running under the remote signed execution policy. So every time Windows PowerShell runs, it looks for this specific file in this specific folder and automatically executes it. It's called a profile. It's kind of like an auto-exec bat file. Every time the shell runs, it runs this. It lets you pre-configure things in the shell, like having it start in a particular folder instead of starting in your profile folder. So there's certainly a benefit behind this. But if a malicious script is going to come in here and modify that profile, then this really is a potential security vulnerability. Let me show you how this is a security vulnerability. Let's say I start off with my Windows PowerShell profile. Let's say I go ahead and create one for myself. And I've got it doing a few harmless things like cd / just to set the shell up the way I want. I'm running under the remote signed execution policy, which means this local script will run without having a signature. And you saw me just do that. So now, a few weeks down the line, I really have forgotten about my profile. It just does what I want. And I accidentally download or get some piece of malware on my computer that puts something a little bit more malicious in here. It tries to delete everything on my computer. And remember, I'm not looking at my profile every single day. The next time I run Windows PowerShell, it's just going to execute this. It doesn't need a signature because I'm using the remote signed execution policy. This is a huge problem. And this is why I do not like the remote signed execution policy in a production environment. It just opens up too many opportunities for danger. Let's say, though, that I was running the all signed execution policy, which is the one I recommend for production environments. I create my profile, I put my nice little cd / command in here, and I run set execution policy to apply a digital signature to my script. That's my little signature there. I don't have to think about my profile at this point. Every time I run Windows PowerShell, my profile executes because it's got a signature. Now that same piece of malware comes along. It modifies my profile, but in doing so, it breaks my signature. PowerShell will no longer run my profile. In fact, the first time I try to, I will get an error message because the all signed execution policy is requiring a signature and I don't have an intact signature. This is going to clue me in that something has modified my profile without my knowledge. So I really, really, really recommend using the all signed execution policy in a production environment. Let's take a look at the actual impact of that. I'm going to leave this same profile in place. You can tell that it does not have a signature, no big block of gobbledygook at the bottom. Let's go into PowerShell. My profile runs. Let's set the execution policy to all signed. Close the shell, open it up right again to see the difference. I cannot load the profile. The file is not digitally signed. The script will not execute on the system. Okay, great. Now I could go apply a signature to it and it would execute unless it had been modified. Now you should know that this is not the only file that Windows PowerShell is hard-coded to use as a profile. If you go into the Windows PowerShell folder on the Start menu, open up Documents, go into the Getting Started guide. Round about page 30, you will see about Windows PowerShell profiles. You're going to find that there are 4 files in total that particular Windows PowerShell console is hard-coded to try and find, and if they exist, it will execute them all. It's not enough to not have one because it's easy for a piece of malware to create one. So if you're going to be secure, you need to have the all-signed execution policy in place, and you need to go create all 4 of those profiles, even if you don't put any commands into them, and you need to digitally sign them so that they can't be modified without your knowledge. Once you get all that in place, you'll be fine. Now I'm actually going to delete this profile because I don't need it, and then verify that Windows PowerShell will open up without error. Okay, it's not trying to run a script now, so it's not upset about it not being signed. And I'm going to set my execution policy back to the one I like to use in the classroom, remote signed. So that's sort of how digital signatures play with that execution policy in Windows PowerShell. And that leaves us really with just 2 PowerShell security features to cover. Let's go into, let's see, I've got a folder on this called C Demo, and I'm going to create just another simple little script here. We'll call it test.ps1. And I'll open that up in Windows Notepad, and again, just have it do something simple, write hello, just so that when it runs, I know it ran. We'll close this, and I'm going to open up Windows PowerShell. So let's go to my demo folder, get a directory listing, just to confirm that test.ps1 actually exists, and run it, test. Oh, it's not recognized as a command, a function, or an operable program, or a script file. Now probably I have to put a PS1 on the end of it. No. Okay. Remember I told you about command hijacking. This is how Windows PowerShell helps you visually prevent command hijacking. Let's say that instead of test.ps1, it was dir.ps1. So when I type dir, is it going to run dir.ps1, or is it going to run the dir command and give me a directory listing? Well, the way PowerShell is designed is so that you don't have to remember which is which. A command is never preceded by a path. A script has to have a path in front of its name, even if it's just !/, which refers to the current folder. If I'm not in the current folder, I have to provide an absolute or relative path to the script. Any path that gets me there will do, but I cannot just change into the folder where the script exists and type the name. Without a path before the script name, it won't find the script. It won't be able to see it. Now the last of our security features, and this is probably a good thing to go back into my little demo folder here, is test.ps1. You remember I showed you how with VBScript you just double click a script to run it? Well, with PowerShell you don't. With Windows PowerShell, the PS1 file name extension is actually associated with Windows Notepad, and that's why that little icon is there. In fact, if I change my view to large icons, you can see that test.ps1 is showing, and in fact all these PS1 files are showing the same icon that a text file uses. If I right-click and select Open, it opens in Notepad. If I right-click and select Edit, it opens in Notepad. If I right-click and select Open With, Notepad is my option. This is so that when, not if, users in your environment have a malicious .ps1 email to them and an email that says, "Hi, here's a postcard from your mom. Double-click it to open it." It won't work. They can double-click it to view the script. And I don't recommend that you change this either. This is a great security benefit. In order to run a script, you really have to be inside Windows PowerShell, or run the PowerShell console with several different command line parameters, one of which will run a script. So it's a little complicated. It's not something that you can easily socialize someone into doing. So that really helps sort of lock down the last of the behaviors that VBScript had, which resulted in it being such a security nightmare. In this nugget, we talked about how scripts are really the biggest security concern with Windows PowerShell, and we looked at different ways that Windows PowerShell works to prevent scripts from being a problem. One of those ways is its script execution policy. And I explained how script signing and digital certificates work together to make the execution policy useful. We looked at Windows PowerShell profiles and how, if you're not careful, they can be used to bypass the execution policy or at least give you less security than you might think you have. We looked at two last Windows PowerShell security features, including the fact that a path is required when running a script, and we looked at the fact that the PS1 file name extension association is with Windows Notepad rather than with the shell itself. I hope this has been informative for you, and I'd like to thank you for viewing.